Okay. All right, so just to reiterate, this is part 2 of a talk that I started last week on 12/22/2012 on a historic date in time when the Mayan calendar predicted a certain event was going to occur, which was in my other talk, which is on YouTube, for those of you watching, and you might not need to start with that. That one is called The Mayan Calendar and the Photon Belt, and there's parts 1 through 5, and basically the way that ended was that we have now entered the Photon Belt. At that time, December 21st, December 22nd, December 23rd were the 72 hours where we were in the null zone, the zone just prior to the Photon Belt. This is just, I'm just not used to having a camera pointing at me, you know, but anyway. So today's talk is, now that we're in the Photon Belt, what happens next? And what I want to start off with is showing you a picture to give you an idea of our universe. Okay, now this picture is actually, has anyone ever seen this picture before?
Mm-hmm.
Okay, so what is it?
Galaxies.
Right.
Exposure of a long, many days exposure, so you can see multiple galaxies.
Right, this is hundreds of galaxies, and each galaxy has millions of suns in each one of these white spots, and we are just one tiny sun in one of these galaxies. So this is just a snapshot of part of the universe, to give you an idea of. Have you seen this picture?
Yes.
Okay, so yeah, I just happened to come across this today. All right, so today's talk is going to get into a lot of science, and the only way I can describe this to you is by saying that my son has told me there's nothing I'm about to say that is higher than an 8th grade science level. So it is going to be very detailed, but just pretend you're taking a science class, and that's the length of this talk. And some of you might already know a lot of this, but it has to do with what's occurring, and I have to talk about it in a scientific way. So, and there's five subjects I'm going to cover today. One is, how is the Earth's magnetic field being affected by the photon belt, and how is that affecting us? I'm going to talk about the electric current on our planet, and how did that get affected by the photon belt, and how is that affecting us? And I'm going to talk about the pineal gland, and what role does that have in all of this, and how did that get affected, and how is that affecting us? And also, what do the crop circles have to do with any of this, and Stonehenge and stone structures such as those, and how do they fit into all this? In other words, the last talk covered the history of the universe in relation to planet Earth, and went into a lot of detail. This talk is going to get into all these things that you've heard about, and how does this all affect them, and where do they come from, what do they have anything to do with this. So without any further ado, let me begin. So the inside of the Earth is fire, and 8th graders know this. This is kind of like that show, what's that show about the 5th grader? Are you smarter than a 5th grader? Okay, this is, are you smarter than an 8th grader? That's what today is. The inside of the Earth is fire, which is molten liquid iron, and that's a key thing here, that it's iron. The inside of the Earth is iron, surrounding a solid inner core of iron. This is what moves and generates the magnetic field. It's solid because at that depth, the high pressure overcomes the effect of high temperature, when the liquid rock would have been liquid. Because it's so much pressure, it's actually solid inside. Magma is liquid iron. And again, I'm stressing this iron point because I'm going to hit that pretty hard with why is this magnetic. What we do know about the core is that, as I said, there is a solid inner core of pure iron, and this is the size of the moon. Surrounding that inner core of solid iron is an outer liquid core rich in iron, also the size of Mars. And there's an irregular boundary between the liquid core and the bottom of the rocky mantle, which is towards the upper crust of the Earth now, inside the Earth. This comes mostly from studying how seismic waves travel through the Earth. That's how they came to these conclusions. Most scientists agree, and this is going to get very scientific, but I'm just going to try to just go through it with you. Most scientists agree that Earth's magnetic field arises from convection currents in the liquid outer core, which is a good conductor of electricity. These currents constitute an amplifying, self-sustaining geodynamo. The average magnetic field in the Earth's outer core was calculated to be 50 times stronger than the field at the surface. So the inner core is 50 times stronger than the field at the surface. The radius of the outer core is about half of the radius of the Earth. And again, that outer core is the liquid part. If the core inside the Earth started to cool, that would also cause a loss of motion. Hi, come on in, just have a seat or get yourself some refreshments. We just started.
Hi, oh good. Oh hi.
The planet Mercury also has a large iron core and a magnetic field, though much weaker than the Earth's. Over geologic time, the inner core grows as the Earth cools, because as the lava, the liquid magma inside the Earth cools, that increases the solid part of the inner core of the Earth. Does anyone here know about magnets? Okay, are you familiar with some of this so far? Okay. So iron crystals freeze out at the top of the outer core and rain on into the inner solid core. And at the base of the outer core, the iron freezes under pressure, taking much of nickel is also part of it with it. The remaining liquid iron is lighter and that rises. These rising and falling motions interacting with geomagnetic forces stir the whole outer core at a speed of 20 kilometers a year or so. And Mars, by the way, is a planet that is made of frozen lava. Mars is, yeah, we're recording this for YouTube. Mars is frozen lava. That planet is a red planet. And what, does anyone know why that's red? And I'm only asking certain things just to see, yes.
Hematite.
Okay, yes, because it's hematite, which is part of iron. See, so the planet Mars is red, which is the same thing as the red dirt in Sedona, is hematite. It's iron oxide, making that red color. Okay, Mars, as I said, is frozen lava, and again, realize that as the Earth's center cools, it turns into solid and stops that motion. Mars has lost its magnetic field. Has anyone heard that Mars was kind of like Earth?
Yeah.
Okay, Mars used to be Earth. They actually say that the men on Earth are like the men on Mars used to be. Violent, you know, warring, destructive. So our planet actually is following a similar path as Mars, and Mars is now frozen lava and has lost its magnetic field. Out in space there is no magnetic iron, yet magnetism is widespread. For instance, sunspots consist of glowing hot gas, yet they are intensely magnetic. The Earth's own magnetic powers arise deep in its interior, and temperatures there are too high for iron magnets, which lose all their power when heated to a red glow. So what goes on in those magnetized regions out in space where there is no magnetic iron? It is all related to electricity. Matter consists of electrically charged particles. Each atom consists of light negative of light, which, you know, is empty space, light. Negative electrons swarming around a positive nucleus. This is what matter is, and that's what physics has proved, that there's no such thing as solid matter. Everything is just electrons, protons, and empty space. Okay, so I'm just giving you the background of why the Earth is possibly able to generate a magnetic force field at all. Close to 1800, it was found that when the ends of a chemical battery were connected by a metal wire, a steady stream of electric charges flowed in that wire and heated it. This was just discovered in 1800. That flow became known as an electric current. In a simplified view, what happens is that electrons hop from atom to atom in the metal. In 1821, Hans Christian Ørsted in Denmark found unexpectedly in 1821 that such an electric current caused a compass needle to move. This is pretty much new stuff, in other words. As long as we've been on Earth, they've just been discovering this in our generation, because I'm sure other generations 10,000 years ago knew this, but in our 10,000 year generation. An electric current produced a magnetic force. This was news to them. Somebody named André Marie Ampère in France soon unraveled this meaning. The fundamental nature of magnetism was not associated with magnetic poles or iron magnets, but with electric currents. The magnetic force was basically a force between electric currents. Okay, so the magnetic property becomes even stronger, though, if you do put a core of iron placed inside coils in the center, which creates an electromagnet. That requires iron, but it is not essential. You can have cores that don't have iron, but when iron is added, it increases that magnetic field thousands upon thousands fold when iron is added. In space, on the sun, and in the Earth's core, electric currents are the only source of magnetism. An electromagnet is a type of magnet in which the magnetic field is produced by the flow of electric current. The magnetic field disappears when that current is turned off in that case. Okay, and I want you guys to kind of be using your thinking caps, okay, because this is actually a puzzle that a lot of scientists don't even know. They don't know, why does the Earth's poles switch? They don't know, why does the magnetic field slow down or decrease or increase. So I'm giving you all the facts for this puzzle. And at the end, which this is only one little short section, but at the end I want to see how you put this together and see if you come to the same ways that I put this together. Okay, so I'm telling you that a magnet is stronger when it has iron at its center. And in space there is no iron, and yet there is, the sun is extremely intensely magnetic. And the strength of a magnetic field generated is proportional to the amount of current being applied to it. And again, when you shut that current off, the magnetism is gone. So if you stop in an electromagnet, because the photon belt, see, is electromagnetic light energy. And they were wondering, how is this going to affect us? Everybody thought we're going to lose power, there's going to be blackouts, your cell phone's not going to work, your electricity's not going to work, and yet we're in it. And everyone's saying, oh, well, then nothing happened. But I'm going to give you some facts about what did happen, that we're not looking in the right places. So, an electric current flowing in a wire creates a magnetic field around the wire. And we just have to get into this basic stuff, because I really had to get down to, you know, these kind of facts. Much stronger magnetic fields can be produced if a core of ferromagnetic material, such as soft iron, is placed inside the coil. Because again, the Earth itself, you know, like we take it for granted that it's this living organism, but really it operates like a conductor, and an electromagnetic conductor, and things are happening on that level. So I want you to, I'm breaking it down into this basic thing, but really the Earth, it has this iron core, and this is what's happening. And we have a magnetic field that's being produced. And they just discovered there was iron in the center. So this is all kind of brand new, but you're taking it for granted because you've already had 8th grade science. But this is just a refresher for you. So, as I said, the ferromagnetic core, if you put iron in there, increases the magnetic field to thousands of times the strength of the field of the coil alone, due to the high magnetic permeability of the ferromagnetic material. The main advantage of an electromagnetic over a permanent magnet, where if you stop a current with an electromagnetic, you shut the magnet off. With a permanent magnet, where that doesn't happen, is that the magnetic field can be rapidly manipulated over a wide range by controlling the amount of electric current. This is the advantage of an electromagnet over a permanent magnet. However, a continuous supply of electrical energy is required to maintain that field. So in other words, we're getting into why does the Earth spin? How is it generating this? And okay, so this is, and it's saying that in an